So hello everyone, welcome to UniVoyage. This is Rushil Shekhar, and today we're going to solve the second part of sequences in series. We've got some additional questions from previous year papers, and let's begin to solve them. So I hope that you've already gone through the first part of the session, and today we're going to solve some more sums based on sequences in series, some higher level sums which have already come in previous examinations. So let's begin. So this is the sum of the first n natural numbers. This is the sum of squares of first n natural numbers, and this is the sum of cubes of first n natural numbers. So I hope you make a note of these three formulae. So the first thing in this question is that we need to find the common term first of all. So we can find that out, and you can clearly see the first common term we can find is 5, right? So we can write our first common term as 5. Also, let's just write the A and D of both these sequences. So let's call this A1, which is 2, and you can see D is clearly 3. D1 is clearly 3. Similarly, A2 is 3 and D2 is 2. The formula of these kind of sums is that here the common difference of the combined arithmetic progression is D1 into D2. Because if you go on to see here, the sequence will be like 3, 5, 7, 9, 11, and even the term 11 is present here. So you'll eventually derive this formula if you go on to deduce it logically. So by this formula, we'll get this as 2 into 3, which is 6. So we know our common difference, we know our A, and we know that the maximum value that our sequence can attain is 101 because this is the smaller value out of these two. Let's keep our AN as 101. So this is the maximum value it can attain, so we need to check that, right? So the formula is A plus n minus 1 D is equal to AN, right? But we're not sure if it's 101. It can be less than or equal to 101. A is 5 and n minus 1 into 6. So n minus 1 into 6 and 6 would go down here. So it will be 96 divided by 6, which is 16. So where n comes out to be less than or equal to 17. So the value n can attain here is 17, which is the correct answer. Let's go ahead. So this is the question of Ipmat 2020, and let's see the question. So if 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square soon up till infinity is pi by 6, then 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square is equal to. So what we can do is that we can call this as S. So let's write S is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square soon up to infinity. And we'll also make one alternate sequence where there are only all the even parts of the sequence. So let's call that 1 upon 2 square plus 1 upon 4 square plus 1 upon 6 square. Alright. So let's solve this part first, and then we can actually just subtract S dash from S to get our answer. So how can you solve S dash? So we can write S dash as, which is sigma r is equal to 1 till infinity 1 by 2r square, right? So if you put r, the value of r is 1, you will get it as 2. If you put the value of r is 2, you will get as 4, and you keep adding these values, right? So what we can do is that we can take this constant 2 square outside. So what we'll get is 1 by 4 sigma r is equal to 1 till infinity 1 by r square here. And now if you notice that this forms that equation which we have at the beginning, which is s. So if you substitute the value of r, you get 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square to infinity. And you can write this as 1 by 4s. Right? So you got s bar as 1 by 4s. So what is our question? So this question is basically s minus s bar. Am I right? Because if you subtract all these even terms from the total equation, then you will get this equation. So we can do that. Basically s minus s dash is equal to s minus 1 by 4s, which is 3/4 of s. So what is the value of s given here? The value of s given here is pi by 6, and you can write this as pi by 8. That will be your answer, option B. Let's go ahead. Okay, so in the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and so on, where n consecutive terms have the value n, the 158th term is. So this is a trial and error question. You have to put in values and understand the pattern here. So let's approach it in a particular way. So you can see that number 1 ends at the first position. The number 2 here ends at the third position. The number 3 here ends at the sixth position. And the number 4 here ends at the 10th position. So can you notice a pattern here? 3 can be written as 1 plus 2, 6 can be written as 1 plus 2 plus 3, and 10 can be written as 1 plus 2 plus 3 plus 4. So here the numbers are ending after they're being added to the sequence, right? So if you notice that this pattern can be formulated as n into n plus 1 divided by 2, which is the sum of n natural numbers, and we have to find the n such that it is equal to 150. So we have to find what value will the 150th term take. Let's take 15. So 15 into 16 by 2. The number 15 will end at the 120th position. And now if you go on for 16, the number 16 will start at 121 and will go until 136. So this is where the number 16 will end, and from 137 till 153, the number 17 will be repeated 17 times. So in between this we have 150, which is our question, what is the 150th value, and this is precisely 17. That is our answer, option B. If the first, second and last terms of an AP are A, B and C respectively, then the sum of n terms of an AP are. So what we can do is that we can write this is D is equal to A2 minus A1. Right. Here the second term is being given as B and the first term is anyway A. So D can be written as B minus A. Let's keep this relation in mind. And we know that AN is C. This is the last term. So let's write this equation here. So A plus N minus 1 D is equal to C. So we can write this as A plus N minus 1 into B minus A is equal to C. So A plus N into B minus A minus 1 into B minus A is equal to C. You can write this as n into b minus a minus b plus a and another plus a here, which is equal to c. So n into b minus a is equal to c plus b minus 2a, and here n is equal to c plus b minus 2a upon b minus a. Let's just keep this in mind. And now if we want to find the sum, Sn is equal to n by 2 into the last term plus the first term, right? So we can write this as a plus c. This can be written as c plus b minus 2a divided by b minus a into a plus c, and this is similar to the answer option A, or it should be A and not C. So this is similar to the answer option A, and that is our answer. Let's go ahead. So what we can do for this is that we can take 7 common, 0.1 plus 0.11 plus 0.111 and so on. And then if you want to make it a sequence with which we can work with, then you can actually divide by 9 and see how it goes. So this can be 7 by 9 into 0.9 plus 0.99 plus 0.999 and so on. This still doesn't form a pattern, a clear pattern with which we can work with. So we write this as 7 by 9 into 1 minus 0.1 plus 1 minus 0.01 plus 1 minus 0.001. I can work with this pattern as I can write this as 1 into 20, and this I can write in the form of a GP. So we can write this as 7 by 9 into 1 plus 1 plus 1 minus 0.1 plus 0.01 and so on. You can write this as 7 by 9 into 20 minus, now we have to apply the formula for GP, 0.1 into 1 minus r raised to n, here n is 20, upon 1 minus 0.1. This we can write as 7 by 9, and this would be 20 minus 1 minus 0.1 raised to 20 divided by 9. So here the decimals get cancelled by 1 and 9, and we'll get something like this, and this you can write it as 7 by 9 into 9 into 20 minus 1, which is 179 minus 0.1 raised to 20 divided by 9, and this you can finally write as 7 by 81 into 179 minus 10 raised to 20. You can write 0.1 raised to 20 as 10 raised to minus 20, and this would be a final answer. 7 by 81 into 179 minus 10 raised to minus 20. So if a1 plus a2 plus a3 plus an is equal to 3 into 2 raised to n plus 1 minus 2, for every n is greater than 1, then a11 equals. So let's just take first few terms. Let's write a1 as 3 into 2 raised to n plus 1. So this would be 2 square minus 2, which is 3 into 2 is equal to 6. A2 is 3 into, so basically A1 plus A2, which is 3 into 2 raised to 2 plus 1, which is 2 raised to 3 minus 2, 18 minus the first term. So A2 would give you, A2 is basically 12. Similarly, A3 would be equal to 3 into 2 raised to 4 minus 2, which is 14, minus the addition of these two, which is 18. This is 24. So can you notice a pattern here? Like 6 can be written as 3 into 2, 12 can be written as 3 into 4, and 24 can be written as 3 into 8. There's a power of 2 which is working here. So if you go on in a similar fashion, you will get A11 as 3 into 2 raised to n, right? Because A3 is 3 into 8, which is 3 into 2 raised to 3. A2 is 3 into 4, which is 3 into 2 raised to 2. So similarly, A11 is equal to 2 raised to 11 into 3. So you need to know your powers of 2 till at least 12, and this saves you a lot of time. And here the answer would be 6, and 48 threes are 6144. This is the final answer. This I think was a short answer type question in CAT 19. This is for a practice. So the sum of first 12 terms of a GP is equal to the sum of the first 14 terms in the same GP, and sum of first 17 terms is 92. So what is the third term of the GP? So we can just write this in terms of a formula in A into R raised to 12 minus 1 upon R minus 1 is equal to A into R raised to 14 minus 1 on R minus 1. So let's assume that R is more than 0 in this case. It won't make a lot of difference if you take R is less than 1 also. So your 1 and 1 get cancelled here. So you'll get R raised to 12 is equal to R raised to 14, and R square is equal to 1. So you can get two values of R as 1 or as minus 1. So let's solve this logically from here. So we'll assume that there's a sequence 10, 10, 10, 10. So here R is equal to 1. So the sum of the first two terms is 20. Sum of the first four terms is 40. So it's not matching with what we want. Let's take R as minus 1. So let's take it as 10 minus 10, 10 minus 10. So here R is minus 1, and the sum of the first two terms is 0, and the sum of the first four terms is also 0. So R should be minus 1. I'll also explain this to you through the formulae. So we can write this sum of the first 14 terms as sum of the first 12 terms plus the 13th term plus the 14th term. These two are the same. So we can write this is what A13 plus A14 is equal to 0. Let's take this term as K. So this term will automatically become KR because this is a GP. And K into 1 plus R is equal to 0. So from here you can get R is equal to minus 1. But you should be able to do this by logic and save time. So the sequence I written as A minus A, and so on. And the sum of any even number of terms here is 0. So eventually you will deduce that the sum of terms is equal to the odd term here. So the value of every odd term is same, right? Which is A, and the value of A17 hence would be 92, And so will A3 be equal to 92? So just make sure that you're able to identify the pattern and are able to implement it in the sum. So thank you for watching this video and hope you enjoyed the session and got a deeper insight into how to solve questions based on sequences and series. And if you have any doubt, you can comment in the comment section or ask us on the Telegram group. So please like, share, and subscribe to this video because we are IPM. I am Indore students who are taking out time for you guys, and I hope that you guys can at least subscribe to our channel and help it grow and reach other students who are in need of such resources. Thanks a lot and hope you enjoyed the session.